All right, so I hope you did well on the test and you just finished talking about triangles. So try again means three-sided figure, and we were just talking about the properties of triangles, and now we're going to move up in the world and we're going to add a side and add an angle. And we're going to talk about the properties of quadrilaterals and parallelograms. So quad means four, just like tri means three, so it's going to be a four-sided figure. And so if you wanted to draw the quadrilateral math, this would be one way to do it out of an infinite many ways that you can actually draw math. All right, so just like we've been doing triangles, we're now going to talk about the different properties of quadrilaterals, and today specifically we're going to talk about a special type of quadrilateral called a parallelogram. And so the first thing that you have to know is that a parallelogram has two pairs of parallel sides. That's the definition. And again, these arrows indicate that they're parallel. All right, the second thing that you have to know about a parallelogram is this property. The property is that opposite sides are congruent. So these sides here are going to be congruent to each other, and these sides here are also congruent to each other. And this should have another equal sign. All right. Property number 2 is that opposite angles are also congruent to each other. So these angles are opposite each other, and these angles are opposite each other, so they are congruent as well. So if I said this angle had a measure of 87, then this one also has a measure of 87 degrees. Property number 3, these are all specific to parallelograms. Okay, property number 3 states that if you have two angles on the same side, we call them consecutive or same side interior angles. Now let's think back a minute to when we learned about parallel lines cut by a transversal line. And we did that XO, 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 XO. Well, these lines, these angles right here are what we call same side interior angles. And you'll notice that they're not going to be congruent to each other, but they're going to add up to 180 degrees. So we call them supplementary. So that's why I wrote here, if you take angle X and add it to angle Y, it will always equal 180 degrees. And that's one of the properties of a parallelogram. And the last property we're going to talk about are that if you were to draw two diagonals that connect the opposite corners together, then what you would end up with is they bisect each other. So you have equal distance here to here. So if I said that this distance had a distance of X, this one also has a distance of X, and the length of the entire side would be X plus X, which equals 2X. Okay. If you didn't get all these notes down, just go ahead and pause the video and make sure you write them down. So here's a funny joke that you can read. Let's move on. I thought that was pretty funny. All right, so let's look at some examples of problems where we can apply these properties to answer some questions about some parallelogram. So this I got a parallelogram. Notice a parallelogram kind of looks like a diamond. One thing I can tell you for sure about a parallelogram is that the angles are not 90 degrees. All right, so what is the measure of angle S? Well, let's take a look at our properties. And I'm looking at the relationship between S and U, and I notice the property of opposite angles are congruent. And so what I know is that angle S is going to equal 34. All right, and I look here, what is the measure of angle T? Well, I'm looking at the relationship between these two angles. They're not opposite each other, so my other option is they're going to add up to 180. And I know this because same side interior angles equal 180 degrees. So I'm just going to subtract 84, and I get x equals, what is that, 96? Yeah, 96 it is. Let's get a little bit more complicated. All right, so now I'm looking at this parallelogram XUVW, and I'm going to look at the relationship between these two angles here, and I notice they're not opposite each other, so they have to be, I'm so used to writing SSS from triangles, they have to be same side, interior equals 180. That's my justification. So I'm going to add them up. Remember, blank plus blank equals 180. So I'm going to take these two, because they're like terms, and I'm going to subtract them from 180. And I've got 39x equals 78. Divide by 39, and x equals 2. We'll look back at the question. What is the value of x? X is 2. Next question. Next example. It says, what is the value of the angle R? And so I'm going to look at the relationship between the two values that I'm concerned about, and I notice they're opposite each other. So my justification is opposite angles are congruent. All right, and I want to know in this problem what the measure of angle R is. But first, I got to find out what x is so I can plug it in, right? So I'm going to set these two equal to each other because they're congruent to each other. So I'm going to add 1 and subtract 15x on the side. So I get 16 equals 2x. So I know my value of x is 8. But now I got to go ahead and plug it in to this equation. And so I'm just going to do angle R equals 15 times 8 plus 15. And I get 135. So if I know this angle is 135, I know that this one is 135 as well. All right, next I'm going to look for the measure of G, and I'm going to use a similar property, but I notice the measure of G is way over here. That's what I'm looking for. So I'm going to have to do a couple steps on this one. The first thing I notice is that these angles are opposite each other. And so I know that opposite angles are congruent. So I'm going to set them equal to each other so I can figure out what x is. All right, so I'm going to add 2 and subtract 7x. And so I get 1x equals 6. So now I know that x is 6, but I do have to do step 2. And step 2 says that I need to find g. And so I'm going to look at these angles right here, and I notice they are same side interior. So I did it again. Same side interior angles equal 180 degrees. So I first have to figure out, by plugging in, 7 times 6, whew, this is a good problem, is 42 plus 4 is 46. And now I'm just going to take that and subtract it from 180. Because I know that these two together are going to be 180. And I end up with 134. So I can say that the measure of angle G equals 134 degrees. That's about as complicated as we're going to get at this point. Let's do a couple more examples. Now we're going to look at sides. So we noticed in the beginning that not only are the opposite angles congruent, but opposite sides are also congruent. So I can say that opposite sides are congruent. That's my justification. So I'm going to set up an equal sign. 2x plus 15 is going to equal 15. Oh, this is going to be a weird problem. So when I subtract 15, I get 2x equals 0. Divide by 2, so x is actually 0. Oh, and if I look at it, the only way I can get 15 here is if x is 0. So that is correct. Next problem, I'm looking for a missing angle. It's right there. I'm going to look at the relationship between what is given, and I can draw a box around that so I know that same side interior equals 180 degrees. So I'm going to call this x for the moment. So 25 plus x plus 116 is going to all equal 180 degrees. So if I combine the 25 and the 16, I'm going to end up taking away 141, and I'm left with 39. So x equals 39. And this is degrees. Let's go ahead and look at this next parallelogram. Two sides are parallel. So I see here E and D. So if I'm looking for the value of x, I see that these two, well in this case these three angles actually, are going to be same side interior, and they're all going to equal 180 degrees when I add them all up. So this is 55 plus 40 plus 29x minus 2 equals 180. And I end up with, go ahead and work it out, pause the video, work it out, and see if you get x equals 3. All right, now let's look at some bisector problems, and then you'll get a chance to practice on your own. All right, if I said that these bisect each other, by, which is right here, is 19.3, well, I can say that this part right here is also going to be 19.3 because diagonals bisect each other, and the word bisect means to cut in half. But the question is asking me for the whole side from B to D, so I just have to take 19.3 times 2, and you get 38.6. You can also add them together. All right, here again, if I know that this entire length is 22, and I know that this side right here is 2x plus 5, then this side right here is 2x plus 5. So 2 times 2x plus 5 equals 22. So it's going to be 4x plus 10 equals 22. 4x equals 12. So x equals 3. And my justification for this is that diagonals bisect each other. And bisect again means to cut in half. Now if you're wondering how I did this step right here, please note you could also add these together and you would still get 4x plus 10. So if I did 2x plus 5 plus 2x plus 5, if you combine your like terms, you still end up with 4x plus 10, which is what we did here. And that whole part is going to still equal 22. So that's 2 ways you can do it. All right, go ahead and get started on your practice problems. On IXL, you're going to do N2 and N3. And the homework is attached. We'll work more on the homework on Monday when we come back. But go ahead and get started practicing these problems and see if you need any help. I'll come around and help you. All right, awesome. Have a good weekend.